So we're going to look at the second part of unit circle trig, which basically looks at how we can find all 6 trig functions of those angles. 30 degrees, 45 degrees, and 60 degrees. So in order to do anything with unit circle trig, what do you have to have for every problem? You've got to know the what. Yeah, you got to know the coordinate. Okay, so our goal is going to be to try to figure out the coordinate of those 3 angles. Right? And once we know the coordinate, it never changes. Okay, it's the same coordinate for every problem. All right, so start out with this one. So what I've done is I've marked the 45-degree point. All right, so 45 degrees is exactly halfway between 0 and 90 on that circle. Okay, so the angle we're looking at is right there. Okay, so here is our 45-degree angle. Any questions why that's 45 degrees where I put the dot? All right. So what we're going to do is we want to figure out, starting from here, that's the origin, how far to the right do you go and how far up do you go. So what we end up doing is basically making a triangle, okay, out of that picture. So let's draw. What I'll do is I'll change the color so you can actually see that. All right. So I have to go that far to the right, and then I have to go, well, it's a little bit off, but about that far down. Now, in terms of left and right, what letter do we usually use for the axis that goes left and right? Andrew? X. Yeah. So this distance from, let's do it with red, between this red dot and this red dot, that's how far to the right you need to go to start to get to this green dot. Okay, that's our goal. So you have to go right x units, and then you have to go up. What letter do you think we're going to use for that? How about Sebastian?
Y.
Yeah, we're going to use y. Okay, so to get from that dot up to that dot, or we'll just make that distance green, whatever. That's y units. So x and y represent the lengths of the sides of the triangle. So all we have to do is figure out how long is the bottom of the triangle. That's how far right you go. And how tall is the triangle. That's how far up you go. And that's your coordinate. Now, we don't know what x and y are yet, but anybody think they have a guess how x and y compare to each other? If you did know the 2 values, yep, they're going to be the same, right? So when we actually set this up in a formula, we're not going to have to use 2 different letters because they're not 2 different numbers. The x and the y are the same. How do you know they're the same? Yeah.
It's a 45-degree angle, so both right sides would be the same.
Why? How come if it's a 45-degree angle, both sides are the same?
I don't know, just something I know.
Anyone know why? Yeah.
Because it's the same angle on both sides of it. So because you have a 90 degrees and you have the other 2 angles that are equivalent, that means there are 2 sides that are going to be equal to each other.
Why is that 45? I don't have that labeled as 45.
Well, a triangle is supposed to have 180 degrees altogether.
Yeah. So all the angles have to add up to 180. And because you have two angles that are the same, that makes it an isosceles triangle, right? Two angles the same, the sides are also, two sides are the same. So that's why x and y are the same, because it ends up being isosceles. All right, so I'm going to draw that same triangle just bigger over here so I have more room. You don't have to redraw it bigger, but it'll just give me more space. So I've labeled everything we have on the left, except I also labeled the hypotenuse. How do I know the hypotenuse is 1? Yeah.
It's a unit circle.
Right, that triangle is in a unit circle. So remember, the distance from the center to the edge is always 1 unit. Now, unfortunately, the 1 isn't really part of the coordinate. The x and the y are part of the coordinate. So I need to figure those out. And in a second, we'll put our coordinate right there. All right, so we said the two sides are the same. So what I'm going to do is just pick a letter. It doesn't matter. But use the same letter. Like when we do Pythagorean Theorem, we usually use A and B for the sides. Well, use A and A, okay, because they're the same length. If they were different, you'd have to use A and B. That would be a little bit of a problem, but we don't have to look at that yet. Okay, now I kind of already said this, but there's a theorem you can use that connects those three sides in a triangle. So we can figure out the length of A. Does anyone remember the name of that theorem? Yep, the Pythagorean Theorem. Can you tell me what that theorem is, Isaiah?
A squared plus B squared equals C squared.
Okay, now how's that going to look with the letters and numbers I have?
It would just be A squared plus
Oh.
A squared equals 1 squared.
Yeah, A squared plus A squared equals 1 squared. And now we're just going to solve that equation for A. So Yashira, I have A squared plus A squared. Are those like terms? Yeah, so I can combine them together. What's A squared plus A squared?
Isn't it just a to the fourth power?
That'd be if you were
Or
multiplying.
it'd be 2a to the second power?
Yeah. So 2A squared. Think of it as like a 1A squared and a 1A squared. Now you have two of them. All right. Now you got 2 steps left to get A by itself. How about Elizabeth? What would be my next step here to start to get A alone?
Figure out what 1 is.
Figure out what. Can you say that again?
When you try to figure out what 1 is, like the side.
So eventually, you want to get rid of this, and then you want to get rid of that. So those are the two things you want to try to get rid of and put them on the other side.
So multiply by 2 on the other side.
Close. I like the idea of working with the 2, but if you multiply by 2 on each side, then you would have this. 4A squared equals 2.
Divide by 2.
Yeah, let's divide by 2 on each side. All right, so divide by 2, divide by 2. Now that's gone. Okay, you know what? I got a little more space. All right, so now we've got A squared equals 1/2. I'm just going to go up here so people can see. But I don't want to know the length of the side squared. I just want the length of the side. I want just A. So how am I going to get rid of the square on the exponent of A?
Find the square root.
Yeah, I'm going to take the square root. So take the square root of what's on the left, do the square root of what's on the right. Here they cancel. And we've looked at this before. How do you take the square root of a fraction? What do you have to do to take the square root of a fraction? Yep.
Don't you multiply by the reciprocal?
That's if you're dividing two fractions. Yeah. So it's even simpler than that. You pretty much do what you would kind of hope you could do. Yeah.
You can square it.
Well, we don't want to square it, because if we square it, then we're going to get this. We're going to go right back to where we started. So we took the square root to get rid of the square. So we want to keep that. But how do we square root that fraction? Yeah.
Change the decimal?
It's going to be easier to leave it as a fraction. So it's a good guess, but we want to leave it as a fraction. Any other guess? Yeah.
You should just flip it.
So I think that's what Matt said about flip like the reciprocal. So you do that when you divide two fractions. If you had something like this, then you would do like 1/2 times 4/3 and stuff like that. Any other guess what we do there? Yep.
Wouldn't you just make it a quarter?
You're thinking of squaring it. If you take 1/2 and you square it, like 1/2 times 1/2 is a quarter. But we're doing the opposite of squaring. We're square rooting. Well, how many? If you look at a fraction, how many parts does a fraction have? 2, right? You're taking the square root. You just take the square root of both parts separately. That's it. So take the square root of the top and then the bottom. So what's the square root of the top? 1. And can you do the bottom? Like square root of 2, do you get a nice answer? No, so we just leave it.
Yeah, it's square root of the bottom.
Right, so we can't have the square root at the bottom, so how do we fix it? We're going to multiply top and bottom. So what does that leave me with in the top? Yep, square root of 2. And what does that leave me with in the bottom? Square root of 4, which is 2. So now we know the length of the bottom side of the triangle, and we know the height. They're the same number. They're both square root of 2 over 2. And we saw square root of 2 come up yesterday. We didn't really know where it came from, but that's where it comes from, right there. So, now that we know that number, anybody think they can tell me the coordinate for 45 degrees? Yeah?
The square root of 2 over 2.
Yep.
Square root of 2 over 2.
Exactly. Square root of 2 over 2. That's the length of the red side. That's how far right you have to go. And then from the red dot up to the green dot, it's also square root of 2 over 2. So that's the coordinate for 45. Now that we know that, we never have to go back and figure that out again. Okay, we're just going to remember the coordinate for 45 degrees is square root of 2 over 2, comma, square root of 2 over 2. Okay. Any questions on how I use Pythagorean theorem to figure out that coordinate? All right, so now let's try a problem using that. So let's find the 6 trig functions of 45 degrees. All right, so they've given me the angle, a 45-degree angle. But in order for me to do unit circle trig, what do I have to know? I have to have the coordinate. Okay. Can't do this unless I have the coordinate. So Anthony, what's the coordinate that goes with this angle?
Square root of 2 over 2.
Yeah.
Square root of 2 over 2.
Yeah. And now from here, we did this problem yesterday. This was I think this was the second example in the notes.
You got it in the homework too, right?
Yeah, I think it might have been in the homework too, or something similar. There could have been a negative with one of these, but
Yep.
Yep. So now we will go through it, but we've pretty much already done this problem. The only extra step you had to do was know the coordinate. Okay, but now we know how to do it. Right. So let's do our sine. Courtney, what's going to be the sine of 45 degrees?
Square root of 2 over 2.
Now, which one did you pick, just so I know?
The one on the right.
Yeah. It's the y value. If you mixed it up with x, you'd be okay with this problem, but in general, you shouldn't mix them up. So, the y value. Cal, what about my cosine?
Square root of 2 over 2.
Yeah, and this time it's the one on the left. Okay, the x value. And now to get the tangent, we have to divide y by x. So Matt, what do you get when you divide those?
Well, you get square root over 2 over the square root of 2 over 2.
Yeah, so you get
I don't know.
square root of 2 over 2 over the square root of 2 over 2.
So you have to multiply it by the square root, right? Because there's a square root on the bottom.
So what did you want to say? You said multiply by...
The square root, right?
Well, when you divide fractions, what do you multiply by? Anytime you have fractions, you said it earlier.
Oh, there's
The reciprocal. So, I mean, you can do all this, so we can flip the one that's in the bottom. And what happens, Matt, when you go to multiply here?
It just equals 2.
What cancels out?
So it's 1.
Yeah. So if we notice that right away, y and x are the same. Anytime you divide two things that are the same, you just get 1. So let's do the cotangent, because that one will be quick. Brianna, what would my cotangent be?
2 divided by the square root of 2.
For this one? Cotangent? I'm just skipping to this one because it's quick.
It's 1.
It's 1, right? So the tangent is 1 over 1. We flip it, we get 1 over 1. Sometimes if I see one that I think is quick to do, I just get that one out of the way. Right, and now I think you were telling me the cosecant. Can you just say what you said again for cosecant?
2 divided by the square root of 2.
Yep. So 2 divided by the square root of 2. And does anyone remember what you get for the final answer once you fix that and reduce? You get 2 square roots of 2 over 2. And then what would be the final answer from that?
Square root of 2.
Just the square root of 2. Yep. And now what about the secant?
Same thing.
Same thing. The sine and cosine were the same. So same thing. Okay, so again, in the homework tonight and on the test, that would be 6 questions, all separate. Okay, so any questions on finding the 6 trig functions of 45 degrees? All right, now, let's say, I just want you to watch this part. Okay, just watch this. This is 90. That's 180. That angle right there is 135. It's exactly halfway between 90 and 180. We did this coordinate a minute ago, right? We made this triangle. Oh. Anyone have a guess at what the difference would be for 135? It's very similar to 45. There's just one thing that's different. Yep.
It's just going to be negative on the x-axis.
It's just going to be negative on the x. That side is still root 2 over 2. That side is still root 2 over 2. You just have to remember when you write the coordinate, you went left. So that's negative, positive. That's the only thing that's going to be different tomorrow. Okay? When we do a 135, you're going to have a negative on the x. Okay? Same thing if you go down here. Okay? It's just, they're both going to be negative. And then if you're in quadrant 4, your one value will be negative again, just your y. Okay? So if you can remember root 2 over 2, that's all you have to remember to do a 45-degree angle. Sometimes you put a negative in front of it, sometimes you don't. Just depends on what quadrant your 45-degree angle is in. Okay, so that's more. We're gonna look at that tomorrow. Okay, We're also going to look tomorrow, what happens if you have an angle that's not a multiple of 30 or 45? You can't do what I've been teaching you. It won't work. Like if I said find the sine of 18, you can't do that one. So for that, we just plug it in on a calculator. So I'll show you how to use the calculator tomorrow. All right, so let's take a look at this. So it's same type of setup we had when I went through how to find the coordinate for 45. We're going to do it now for 30. Okay, so this is 0. That's about 30, 90. So 30 is about 1/3 of the way rotating through quadrant 1. Okay. Here is your angle. 30 degrees. Now, if I set this up like I did the last one, what shape am I going to make out of that? Yep, we're going to make a triangle again. So that's going to be longer than I need, but that's okay. So what I did, I just put in a vertical line from 30 degrees straight down to the x-axis. So to figure out the coordinate for 30 degrees, what do I need to figure out in that triangle?
Your other angle.
Okay, we can write down the other angle if we want. We don't need it, but what is it?
60.
Yeah. So this angle up the top is 60, because we said earlier they all add up to 90. So knowing that's 60, that doesn't tell me the coordinate though. What do you have to find in that triangle that we still don't know? Length of what?
The sides.
Which sides?
The one.
Okay, the length of the side on the x-axis. You gotta find that. And what other side did you say is it? Going up. If we can find the length of the side in red, that tells you how far right to go. And the length of the side in green is how far up. All right. And let's label them just like we did last time. I was going to use black, but I guess not. So the length of the horizontal, that's x. And the length of the vertical side in green, that's y. Now, same question I asked last time. We don't know x and y. But if you compared them to each other, what would happen this time? Yep.
Well, would it be twice as much?
Well, we don't know necessarily if it's going to be twice as much, but it is going to be bigger. All right? Just because it's across from an angle that's twice as big doesn't necessarily mean the side is twice as big. Right? I see where you would think that though. Right? But definitely one is bigger than the other. So they're not the same. So we can't do the same trick we did last time. Okay? If you tried to set up Pythagorean Theorem, how many variables would you have in it? Well, there is actually one side of that triangle we do know. What's the length of the hypotenuse? 1. How come? Because of the unit circle. So we do actually, we know that. So same triangle, just a little bigger. So that side is 1. So we would only have 2 variables in the Pythagorean theorem. But that's still a problem. You can't solve an equation with 2 variables, right? If I just gave you this and said add 2 numbers together and get 5, what's the answer? Well, there's a lot of answers. 1 plus 4, 2 plus 3, 0 plus 5. You don't have enough information if you've got 2 variables in the same equation. So we have to figure out one of these other variables somehow first. And you have to be pretty clever. It's not hard to understand once you know what to do, but you have to be pretty creative to think of this. It's simple, but you have to be Kind of smart or creative to figure that out. Anyone have a thought of what we can do? And I'll give you a hint. It involves adding something to that picture. No guess on what? So what about if I did this? Well, first I need to put all that together. Let's group all that. Now let's go like that. Okay. Yep.
Can you stack them on top of each other?
How do you want to stack them together?
So that, like it kind of looks like a square.
So it looks like a square?
Yeah.
So I'd have to flip that. How would I flip that? Like that?
Yeah.
Okay. It's not perfect, but. So yes, I now have a rectangle. Okay, now what? Because I don't know what to do from there. I really don't. I'm not sure.
Did you take all those coordinates and like, I don't know, use the slope or something?
I'm not sure how we could. I'm not sure how we could do it this way.
Yeah, I don't know how to go from there.
Yeah, I'm not sure either. Let me put it back the way I had it. Does anyone have another idea? But that was a good thought. You're kind of on the right track. What else could I do? Yeah?
Would you flip that one so it's facing the other way and then put them together like?
Flip it. How do you want to flip it? Which way?
Like so the 90-degree angle is like facing the other one?
So you were thinking of flipping it like this way?
Yeah, and then putting it next to each other so there's a like 180-degree angle.
Okay, so you're close, but let me give you a slightly different suggestion. Let's flip it the other way. So I do want to make another triangle here, but let's do it like that. Okay. Now, what's going on in that picture? Yes. I just made an equilateral triangle. Okay. 60, 60, 60. So what does that mean if you have an equilateral triangle?
All the sides are the same.
All the sides are the same. So this side is 1. This side is 1. But the important thing is this side is 1. So that entire side on the right is 1.
That means it's a half.
Means it has to be a half,
Yep.
right? We know that this and this are congruent. Okay, why? Because all I did was make a mirror image of it. They're the exact same length. So if you've got two sides that are the exact same length and they have to add up to 1, that has to be a half. Now we don't have 3 unknowns anymore. So now we actually know the y value is a half. Right? All we need is the x value. We don't need the bottom part of the picture anymore. So I'm just going to move it so it doesn't confuse us. Okay, so we've got the height is 1/2. Let's call the bottom side what we have it labeled, x. Now, how would I solve for x? Yeah, now I can do the Pythagorean theorem, no problem, because I know 2 out of 3 of the sides. Okay, but you had to be a little bit clever to kind of figure out how to figure that out as a half. Okay? And there's other ways too, but it's probably the simplest, I guess. All right, so set up the Pythagorean theorem. X squared plus a half squared equals 1 squared. Okay, what's 1/2 squared? A quarter. Yep, half of a half is a quarter. All right, and now we need to start to get x squared by itself. So Justin, what would be my my next step?
Try 1/4 both sides.
Yep, I'm just gonna move that up a little bit. So subtract 1/4 from both sides. And Justin, what's 1 minus a quarter?
3/4.
3/4. Okay. Let's see, I'm just gonna go over here because if you have more room, you can just keep going. So x squared equals 3/4. And Pat, what's my last step? Well, is x by itself yet? No. What's there that tells you x isn't by itself?
The square.
The square. So what's the opposite of square? How do you undo, like if I gave you a number 9 and I squared it, I get 81. And I said, okay, I want you to turn 81 back into 9. How would you undo squaring it? No, divide is the opposite of multiply. So like if I doubled something and then I divided it by 2, those would cancel each other out. Anyone help them out? How do we undo squaring? Matt? Take the square root. So take the square root. Take the square root. So x equals. How do I take the square root of 3/4?
Take the square root of the top and the bottom
Yep.
separately.
Take the square root of the top and the bottom separate. This time, once we do that, we're done. We don't end up with a square root in the bottom. And that's the final answer for x. All right. So now we know this side is square root 3/2. This side is a half. So how would I write my coordinate for 30 degrees?
Square root 3/2, comma 1/2.
Yeah, square root 3/2, comma, a half. So that is your coordinate for 30. Now, we did the 45, we did the 30. What other angle do we still have to do? The 60. What do we really have to do to 60? Right, so here's the 60. It's like right here. It's 2/3 of the way through the quadrant. Watch what happens if you draw your triangle. How does that triangle compare to the triangle we just did? It's the same thing, but what? It's what?
Double.
Well, is it the same thing or is it twice as big?
It's flipped the other way.
Yeah, it's just standing up on the short side rather than laying down on the long side.
Right.
It's exactly the same triangle. This time, the 60 is right here. So the 60 is down at the bottom, and the 30 is up at the top. 30, I'll just put an arrow, 60. So what do you think the coordinate's going to be for 60 degrees? Yeah?
Would you just flip the
Yeah.
1/2 and square root of 3/2?
Yeah. So now, here's your short side. That's your 1/2. And now here's your tall side. Root 3/2. So 1/2 root 3/2. So when we're dealing with 30s and 60s, you have to remember 3 numbers. Actually, 2 numbers. You have to remember 1/2 and root 3/2. Other number you have to remember is for the 45, and that's root 2/2. Now, it can be a little hard to remember the difference between the 30 and the 60. Right? One of them is 1/2 root 3/2, the other is root 3/2 1/2. It's almost the same thing. So, if you draw your triangle, the way I would think about it is like this. What's 1/2 as a decimal?
0.5.
Right, it's 0.5, right? Let's look at square root of 3 divided by 2. It's a little bigger. It's about 0.87. So keep that in mind. Root 3 over 2 is a little bit bigger than 1/2. So when you draw it, the bigger side is always root 3 over 2. The short side is always 1/2. And if you draw it somewhat to scale, you don't have to remember which number goes first and which number goes second. It'll just happen in your picture. And then you can just look at your picture and say, oh, okay, the big side is going on the bottom, and the tall side is up and down, which would be up and down is your y. Okay. So let's go through it and just see how that works. Okay, so we're going to find the 6 trig functions for pi over 6. Right, so Stephen, they've given me an angle in radians. What might I want to do with that if it's easier for people?
You want to convert it?
Yeah, to what?
You want to do 180 over pi?
Yep. And that's going to change it from radians to degrees. Yep. So, let's see. Let's do that out. And what do we get when you do 180 divided by 6? 30. So every problem in today and in tonight's homework has to either come out to one of the following numbers: 30, 45, 60. Or it could be a review problem from what we did yesterday: 0, 90, 180, 270. Okay, but you know how to find the coordinates now for those 7. All right, so 30. So I know that 30 involves 1/2 and root 3 over 2. I don't remember which one comes first, which one comes second. So draw your picture. 30 degrees is right there. Just make it less than half. Make your triangle. There's your triangle. Okay. Looking at that triangle, where's the long side? Is it the bottom? Or is it the height? It's the bottom. So the long side is the bottom. And what number, root 3 over 2 or 1/2, is the longer or the bigger number? Root 3 over 2. So root 3 over 2 is the bottom. That's my x. And 1/2 is the smaller number. So that goes with the smaller side. Now I write my coordinate, root 3 over 2, comma, 1/2. Okay, so just by trying to draw it kind of to scale, I can tell which side is the long side and which side is the short side. You just have to remember those 2 fractions. But you don't have to remember where they go. Just which one is bigger. Okay, so now let's go through our trig functions. Okay. We might have done one kind of like this yesterday. I'm pretty sure we did. It may have had a negative in here. But now you know where that square root of 3 comes from. Okay. It comes from doing something with a 30 or a 60. Right, so let's start with the sine. How about Riley? What would be the sine of pi over 6?
1/2.
Yeah, it's just the y value, 1/2. Nice and simple, nothing else to do. Okay, Madison, how about my cosine?
The square root of 3 over 2.
Perfect. Just the x value, nothing else we have to do. Okay, and Alex, what's my formula for tangent?
That's y over x.
It's y over x. So if you look up at the work you just did, it's almost like you're just putting a division line right there. That's y, that's x. Just divide those 2. Okay. So, when you divide them, you have a fraction divided by a fraction. Is there anything that's going to cancel out?
Yeah.
The 2's. I'm not going to cross them out because they're part of the other answer, but I am going to rewrite it, and it's just going to be 1 divided by square root of 3. Where did the 2's go? Basically, they went like this. 1 divided by the square root of 3. Okay, so the 2's are gone. And then I just need to fix that so the square root is in the top. Brandon, what would I get when I fix that square root of 3 in the bottom?
Would be the square root of 3 over 3.
Yep, perfect. Square root of 3 over 3. Now, don't get rid of what we have. 1 over the square root of 3, we're going to come back to it. It might come in handy for something else. Okay, how about Emily, what's my cosecant?
2.
Yep, just take the sine, flip it, and you're good. All right, how about Jason, what about, Jason's not here. Stephen, what about my secant?
Would it be 2 over square root of 3?
Yep, it's a good start, 2 over the square root of 3. And Yashira, when you fix that, what do you get?
You get 2 square roots of 3 over 3.
Perfect. Right. And now let's look at the cotangent. Now, when you do the cotangent, you've got 2 things. You could flip, I'll just call them 1 and 2. 1 and 2 are equal to each other. Okay? The first fraction and the second fraction are the same thing. Which one would be better to flip? Why? Not sure. Anyone can support why the second one would be better to flip, or if not, why you think the first one is better? Matt?
The first would be better to flip because it's over 1, so it just needs square root of 3.
Yeah, if you flip the first one, the square root goes to the top and you're done. If you flip the second one, the square root goes back to the bottom, you gotta fix the whole thing again, and you're still gonna get the same answer. So I would just flip the first one. That's why sometimes the work you did throughout the problem comes in handy later on.
It would still be right though if you did it all out, right?
Yeah, if you flipped it, you would get this. And then you'd have to multiply top and bottom by this.
Yeah, that's what I did.
And you get this. You get that, then you go like that. So, yep, you still get the same thing.
Oh. Never mind.
So,
It would make sense to me like on the
any questions on finding those 6 trig functions? Alright, let's yeah. Okay, so let's finish up with this one. Okay, so try that one on your own. Okay, I'll walk around, and if you've got some questions, I'll help you out. But find the 6 trig functions for 60. Okay, we just did 30. So try 60. Alright, so let's start to take a look at it. And what I really want to do when we're done is compare the answers on the right to the ones on the left. So, Emily, what's the first thing you had to do here?
Like find this.
Find
What
the
do you mean?
Well, when you started this out, what's the first thing you did?
I just rewrote the coordinate.
Yeah, you got to write down the coordinate because we don't have it for 60. What did you put down for a coordinate?
I put down 1/2 and then square root of 3 over 2.
Yep. And if you weren't sure, like can't remember which way is which, make your circle. 60 degrees is up here. Just draw it further than halfway. Make your triangle. It's pretty clear to tell in that triangle which side is the short side and which side is the long side. This is the short side. So that's 1/2, and the short side is on the x. So that's your x. The long side goes up and down, that's your y. Okay, so root 3 over 2 is the y. Yeah, so it's perfect. Isaiah, what'd you get for the sine?
I got the square root of 3.
Yep, square root of 3 over 2. The cosine, how about Pat? What'd you get for that one?
1/2.
Yep, good. And Megan, what did you get for the tangent?
Square root of 3.
Square root of 3. So now, if you look at those answers, root 3 over 2, 1/2, root 3. Well, we've got a root 3 over 2 right there. We've got a 1/2 right there. And we've got a square root of 3 right there. So we've already flipped all of those. If you flip square root of 3, you get square root of 3 over 3. If you flip 1/2, well, that's an easy one, you get 2. And if you flip root 3 over 2, you get 2 root 3 over 3. So we got all the same answers, but in different spots. So if you look closely, those two switched. The sine and the cosine, those two answers switched places. So did the cosecant and the secant. Those two answers switched places on the right side. And then look at the bottom. Tangent and cotangent. Those two answers switched places. So if you just read the functions that I put in the green, the blue, and the red box. Sine, cosine. Secant, cosecant. Tangent, cotangent. So those boxes are what we call cofunctions. Cofunction is when you take a trig function and put the word co in front of it. A little different than reciprocal. That's just looking at the rows left to right. Now, tangent and cotangent are actually both. They are reciprocals, and they are also cofunctions. That's special. Okay? But those, the green, the blue, and the red box, those are your three pairs of cofunctions. Well, we're going to talk more about those at some point. Okay. So any questions on the 60 degrees? Okay. So, the homework tonight is a worksheet. That's the first 10 questions. And then there's 5 other questions I didn't get on the worksheet. So you'll have to copy down these 5. Some of the problems we have up there are review from yesterday. So some of those might come out to like 90 or 180, something like that. But the angles are 17 pi over 4, 13 pi over 6, negative 24 pi over 8, negative 15 pi over 4, and negative 46 pi over 8.